How's it going, everybody? And welcome to our next section in the Cisco Enterprise series, where we're going to be diving into RIP version 2. So I'll be going through just a high-level overview of the protocol itself, and then in the following video, we'll go through and dive into the actual implementation and verification of RIP. So this video will be available for free on YouTube. If you want the configuration and verification piece, that'll be a video available through Patreon on the All Access Pass. So without any further ado, let's go ahead and dive into this. I'm going to go ahead and go full screen. So RIP has been around for a long time, also known as the Routing Information Protocol. And I don't know what version of code it flipped over to version 2 or when any of that stuff came into play, but it is a class full routing protocol and was eventually given the option to go classless with version 2. So when you type in the no auto summary. So we're going to go through some of the details of RIP and how it works, and then we'll dive into some of the other operations. So there are some pieces in here where it is good to know the difference between class full and classless routing. So class full meant you didn't pay attention to the network mask. So basically the router would check for the major network in the routing table if the major network exists, but a subnet for the destination does not, drop the packet. Note the default route is not used in this particular case. So if you want to dive deeper into the difference between class full and classless routing, these notes will be made available to everybody via the Google Drive link. It'll be I'll have to see exactly how that's mapped, but it is out there. So I'll probably put a link in the description to this particular set of notes, so in case anybody's interested in diving into those, they can. So when it comes down to classless routing behavior, it has been classless since 11.3, so it's a long time ago. When I first got into the industry back in 2010, I believe the version of code running at least at the CCI lab when I was first introduced to it was 12.4.15. So I don't know when exactly that was released, but that was a version of code that I remember. So things have changed since then. We're obviously now in 17 and change, so RIP has been around for a long time. So basically, if, from now until the end of time, RIP will be classless. So RIP version 2 qualifies as a classless routing protocol as it carries subnet mask info in routing updates. So classless routing rules is not based on IP address classes. Longest match does win. So if a match is not found, the default route is used to forward the packet. If a match is not found and there is no default route, drop the packet. So it is a distance vector routing protocol. Distance meaning how far, and vector meaning which way. This is a little bit different than the path vector, which is BGP, which is which particular path am I going to take, so which AS path, and vector means which direction am I going to go. So there's multiple ways of handling that. The RIP metric is based off the basic hop count. So the metric can be 1 through 16, and a metric of 16 indicates a route that is inaccessible. It does utilize split horizon with poison reverse. Split horizon simply means that you'll never advertise a route out in the interface it was learned on. So basically, if you learned in 10.1.1.0/24 inbound on a particular interface, you're not going to advertise that route back out that same interface. That's what split horizon mean. Poison reverse is advertise the route back out the interface it was learned on, but with a metric of 16, saying this is no longer accessible. Now, there is a scenario in which this changes things. So, in this very small chance that you might see RIP in the real world, and even the smaller chance, we'll say the 1%, that you see RIP being used in a tunneling type of technology like DMVPN, it is possible to break split horizon. And you would basically turn split horizon off at the tunnel level. So if spoke 1 were to advertise a route, say 10.1.1.0, up to the hub could then re-advertise that same route back out of the tunnel, but to a different remote location. So spoke 2, for example. That is possible, and you would type in no IP split horizon RIP, and it would, most commonly it's done with EIGRP, but that's basically the case. It does utilize UDP port 520 at layer 4 for communication. And IP RIP NG or IPv6 RIP uses 521 in UDP. One thing that of note is it uses UDP. UDP means what? It means it's connectionless, which means there's no guarantee of traffic arriving. So RIP is a fire and forget type of routing protocol. You didn't get it? Oh, sorry. Whatever. It doesn't really ever happen, but it can. So there is an administrative distance of 120 is the default, and it does send gratuitous updates every update time, which is a default of 30 seconds. Version 1 of RIP sends the broadcast address of all 255s, which supports the advertisement of /32 host routes as long as it is a subnet in the same major network being advertised. So, for example, it can't be 10.111/32 if major network is 172.16/16. Version 2 utilizes multicast at 224.0.0.9 by default. So it can be configured for unicast updates using the neighbor command. It can be configured for broadcast updates using this if you type in IP RIP version 2 broadcast. The main configuration with the network command will be the network command followed by the major network. You know, your class, your RFC 1918 address space, so your 10/8, your 172.16/12, as well as your 192.168/16. In this case here, I use the 1 dot as the example because it gives a different example than 192.168.0, which would be the subnet 0 base. So basically that's where that would come into play. Now, in case anybody's curious, when it comes to unicast updates with the neighbor command, when would you only be able to use unicast communication? Very rarely would you ever see that, but the reason why they have that out there is because back in the day, and it's still out there sporadically that I still do see. I work in the service provider world, and every once in a while we do see old school legacy frame relay with our customers. So frame relay does have the ability of not supporting broadcast communication. If you don't have broadcast communication enabled on your frame relay environment, you will not be able to support multicast either. So multicast is a subset of broadcast, which is one to many, not one to all. So if you don't support broadcast communications over your media, so in this case here, frame relay, you would be forced to use unicast or the neighbor command. So other than that, if you want to use unicast, you can do that. I'm not going to be giving you an example of how that works. But if you wanted to dive into the configuration guide of RIP and play with it to your heart's content, be my guest. Oh, there was a question asked, what platforms or scenarios could you possibly see RIP being used? And the answer to that question is there are some, I like to refer to as prosumer grade hardware. Like you might get a Netgear device, a firewall, for example, or a router that supports RIP because it's still an open standards routing protocol, just like OSPF and BGP you're still going to see them. IS-IS is as well, but the IS-IS is layer 2, not layer 3. But in this particular case, RIP version 2, I have seen RIP on Netgear, and I'm trying to think what other platform. There's other lesser known non-enterprise grade hardware out there. There might be some implementations of RIP on higher end platforms of D-Link and TP-Link and things like that, but I've only seen it a couple of times on non-enterprise grade hardware like Cisco, Juniper, Palo Alto, things like that. So it is out there. And a fun fact, I wasn't aware of this until I got into the service provider world, but apparently when you're dealing with CMTS, cable modem termination systems, so basically the endpoint in which your cable modems that are sitting at your home or at your business to provide you your business class coax service, the communication on the CMTS to the upstream router in order for you to get out to the internet, that is a RIP connection as well. That's at least what I'm told. I haven't actually seen it firsthand, but it is what it is. So what makes RIP version 2 classless? Well, it advertises the subnet mask in the routing updates, enables the use of authentication, you can tag routes during redistribution, it supports multicast updates, and with the next hop can point to a better next hop if info exists. So as you get into how to enable RIP, you enable it globally, router RIP, you enable the interface process, so you type in the network statement, so any one of the RFC 1918 address blocks. The network command advertises RIP out interfaces that match the major network statement in the network statement. What that basically means is, if you didn't already know this, if you have an interface, let's say you have 3 interfaces configured on your router, one in the 10 network, one in the 172 network, and then one in the 192.168.1 network. What will end up happening is when you use the network command of 10/8, 172.16/16, and then 192.168.1.0/24, as long as you have an interface with those subnet ranges available on a particular interface, it's going to match that interface and allow it to send RIP version 2 hellos out that interface. That is how RIP, EIGRP, and OSPF all operate. It's a IS to IS as well, but slightly different. So that's where that would come into play. The verification commands for RIP are very, very thin. You don't get a lot to work with RIP. So if you want to dive more into how it works in the verification, there's really not a whole lot there. So just be cognizant of those things. Now, there's a whole bunch of additional features and capability that you can turn on, and I'm just going to quick kind of sort of go through what the capabilities are out there for it. There's a lot of detail for this. If you want to dive into it, I will make sure that this particular notepad doc is available inside a Google Drive, and I will link it in the description below so you guys can gain access to it. So if it isn't already available by the time this recording is available, if you already have a $10 a month Patreon access or membership on the YouTube channel, you should already have access to this. If not, I'll go double check the URL to make sure it's there. You can do a lot with redistribution and filtering and things like that. So I'll kind of loosely go through all this stuff. There's a lot you can do with RIP, but just remember that it is a old school routing protocol. There's not a ton that it can do. It does only support a 15 hop network. That's the maximum size network you can support. So because of that, there's not a whole lot of flexibility in what it can do. So now that we've covered those details and all that type of stuff, that is it for this video. If you guys have any questions, comments, concerns, feedback, please leave a comment in the comment section below. In the next video, we'll go through the workbook. We'll be in the topology. We will be configuring RIP, verifying its operations just to make sure we check that RIP routing protocol box. And if you're looking for that video after this one, that will be available through Patreon on the All Access Pass. Until next time, guys, thanks so much for stopping by, and I'll catch all of you in the next video.